Hello, everyone. Hope everyone is having a good day. And we're actually starting a new unit tonight. Very exciting. I am super excited to start a new unit because it is all about math. And I happen to really like chemistry math. So, the unit is called Chemical Quantities. And the reason that we care about chemical quantities is because in real life chemistry, right, when we utilize things in our lab, we don't talk about combining one atom with one atom. We talk about combining actual amounts that we can see, we can manipulate, we can use, people can use, anyone can use. And remember that there was a very special unit that we called a mole, which, of course, is shortcutted to MOL. And of course, remember a mole, which is Avogadro's constant. And we said that we remember that a mole is a unit we have to be able to talk about atoms and molecules on a macroscopic scale. And of course, we also remember that a mole has a number to it. So, like the unit of a dozen, which is equal to 12, or we can say that there are 12 per dozen, right? We also have a mole, 1 mole equals 6.02 times 10 to the 23rd, or we can say that there are 6.02 times 10 to the 23rd per mole. Now, let's actually talk about where that number came from, because it actually wasn't just some arbitrary number that we made up. So if we look at our reference table, we can see that the mass of carbon is 12.001 AMU, atomic mass units. 011 AMU for a carbon atom. And I can also tell you that 1 AMU has a mass of 1.66054 times 10 to the minus 24 grams. And what I'm going to do is I'm going to determine the mass of a mole of carbon atoms in grams, right? So let's convert that AMU to gram first. 12.011 AMU times 1.66054 times 10 to the minus 24 grams per 1 AMU. AMU's cross out. This equals, handy dandy calculator, 12.011 times 1.6605 times 10 to the minus 24, 1.994474459 times 10 to the minus 23 grams of carbon atoms. Okay. Now I'm going to find out what 1 mole of carbon atoms is. So we know that if we want to figure out the mass of a dozen, we multiply by that by 12 to figure out the mass of a mole of something. To figure out the amount of 1 mole of something, we multiply by Avogadro's number. determine the amount of 1 mole of anything, we multiply by 6.022. Oh, I'm sorry. Too many sig figs. Yeah. 6.02 times 10 to the 23rd. Yeah. Just like if we wanted to figure out a dozen, we multiply by 12. So we're going to take that number, this number right here, and then we're going to multiply that by 6.02 times 10 to the 23rd per mole. And that's going to equal look at that. 12.0. It's about 12.001 grams, which is about the same, right? To two sig figs, which I have told you, they're about the same. They are the same, and that's because Avogadro's constant, like I said, isn't just an arbitrary number. Avogadro's constant, that's 6.02 times 10 to the 23rd, is the conversion between AMU and gram. And the cool thing is that we know that the upper right-hand corner is going to be the mass, right? The mass is actually two different things. It's both of them. The mass on the periodic table is both the mass of one atom in the units of AMU and the mass of 1 mole of atoms in the unit of grams. So if we were to quickly look at S, sulfur, on the periodic table, there's sulfur, 32.065. So we could say that the mass of 1s atom is 32.065 AMU. We could also say, which is also true, the mass of sulfur is 32.065 grams per mole of atoms. So that's how that all works. It's really easy. The quantity of that mass on the periodic table is both for AMU of an atom and grams for a mole of atoms. That's why we have that Avogadro's number. Okay, let's do some math. So let's talk about what is the mass of water. Let's say I want to find the mass of water. Well, if I'm in a lab, I don't want to know the mass of one water molecule. I want to know the mass of the whole water, the molar mass, if you will. Ooh, there's a new vocab word. Molar mass. You can get a couple of vocab words today. Is literally the mass of 1 mole of a substance. And of course, that's always in the units of grams, or technically it's in the units of grams per mole. Okay, so what is the molar mass of water? Well, unfortunately, we know that water is a compound, so it's not found on the periodic table anywhere. What is the molar mass of water? Well, we know that the chemical formula of water is H2O, right? So instead of just finding the molar mass using just one element on the periodic table, new vocab word, we're going to find something called the gram formula mass, the GFM, aka the gram formula mass, which is literally the mass of a chemical formula in grams. Okay. So, mass of chemical formula in grams, we know that in H2O, each mole of H atoms is, based on our periodic table, 1.00794 grams. And each mole of O atoms is 15.994 grams. And we know that there are 2 H atoms, or 1 H molecule in a water molecule, right? So to find the gram formula mass, what we're going to do is simply find the sums of everything. So what I would do is I would do 1.00794 grams of hydrogen per mole times 2. Because there are 2 atoms, or I should say 2 moles of hydrogen per 1 mole of water, plus 15.994 grams of O per mole. And the gram formula mass for this is 18.01528 grams of H2O per mole. Right? Easy peasy lemon squeezy. Next one, let's try something else. What is the GFM of iron 2 phosphate? To get the formula, we have to do a little reverse crisscross. We know that the iron has a +2 charge. We look up in our periodic table to see the phosphate has a -3 charge. So we get the formula Fe2, PO4, 3. So we're going to do the same thing as before. So, iron, 18, nope, that's fluorine. Iron is 55,845. So we have 55.845 grams of Fe per mole times 2. And now here comes the tricky part. Phosphorus is 30.97376. 30.97376 grams of phosphorus per mole. Now, it might look like there's 1, but we actually, because of this little subscript 3, that tells us there are 3 phosphates, right? So there's actually 3 P's. And then oxygen is 15.9994 grams per mole for oxygen atoms. Did I get that right? I did. 3 9s and a 4. And then, once again, same thing. We have 12 of them. Oh, no. I screwed this up. Whoopsies. That should be a 3. That should be a 2 because of the crisscross rule. So that's times 8. And then when you add this all up, you get 357.4345 grams per mole. And that is how you figure out the molar mass of anything. Thank you so much for watching today. I hope everyone has a good day. Bye.